Hello everyone, and welcome to a brand new Crazy Data Science video, the YouTube channel that uses real-world data science methods and techniques and applies them to problems you never really thought about or you never really thought you had. So let's start with the question of this video. And the question of this video is from a guy named Bob, and Bob has a really interesting question. He says, "Hey, Crazy Data Science, I'm a big fan of slasher movies. And I've always wondered, would I survive in one of those movie situations? Is there anything you guys can do to predict my chances of survival?" Well, Bob, it's data science. Of course we can. But before we get started at looking at this problem, I think it's good to know what a slasher movie is. So I went to Wikipedia, which is basically the base of all knowledge in the world, and I looked up what a slasher movie is. And according to Wikipedia, a slasher movie is a subgenre of horror films involving a violent psychopath stalking and murdering a group of people, usually by use of bladed tools. Alright. So to give you an idea what it looks like, here's a short part of a slasher movie. For the sensitive people, it's probably a good idea to look away for a couple of seconds.
Please.
Oh my God! Man, that's really heavy stuff. So how are we gonna solve this problem? So basically what we are after is answering the question, will you or will you not survive a situation in a horror slasher movie situation? Basically the approach we are going to use is to apply a software solution, a cloud-based software solution called Azure Machine Learning. That's a Microsoft platform in which you can very easily build and train models and later use the models inside your own software or inside any functionality you basically want. Azure Machine Learning, in my opinion, is a very amazingly good tool, especially for people who want to get started in data science. As you will see a bit later in the video, it's a very visually based tool. It's easy to follow the flow of the data, it's easy to understand, and best of all, I'm Dutch, it's totally free to get started with, which is absolutely amazing. In the second bit, we're going to use a bit of R in combination with a library called Shiny. And Shiny is basically an R library that allows you to make a kind of interactive website in which you can fill in information. And we're going to send it to the Azure Machine Learning model we train and then return a prediction. So this is all like a complete solution to predicting whether or not you are going to survive a slasher movie. So, without wasting much more time, let's get started on building our model in Azure Machine Learning. So, I fired up a web browser, I navigated to my Azure account, and I started up my Azure Machine Learning Studio. And as you can see on the screen here, I created a thing called an experiment, which is basically the way you create a machine learning solution inside Azure Machine Learning. And what you can see immediately is that it's a very visual experience. From my screen you can see the data, basically how it's connected to all different kind of modules. And I'm going to walk you through these modules one by one. And of course we are going to start with the top one, which is basically the data we are going to use to create our machine learning model. And this is a CSV file. It's called Horror Deaths Halloween. And let's see how it looks like. And you can very easily do that in Azure Machine Learning by just right-clicking and using the button Visualize. And this will immediately open up our data set and show us all kind of information, like a couple of graphs and a number of rows and what the content is of the data set. Now, for the people who are a bit familiar with movies, you can see we are looking at data from the movie called Halloween. Halloween is basically one of the first real slasher movies. Uh, and the advantage of using this data set, which I collected and assembled myself, is that the fan base of the Halloween movie franchise, they are very detailed in describing characters and the way they died. So this is very useful because we are going to predict whether you're going to die in a slasher movie, and more specifically, we are going to predict whether you're going to die in a Halloween movie. Now, I don't have that much data. I only looked at the first 4 Halloween movies, Halloween 1 to 4. I basically got all the characters that were in that movie with all the descriptions, like the age, what's the age group, is the male or female, what profession was in the movie, a profession category, if they have any siblings, a partner, what their body type was, and whether or not they are going to die. I also have some information about how they are going to die, but that's not something we are going to use. If you've looked at this data, you immediately see that in Azure Machine Learning you can see some histograms about the possible values. So we have yes, no, and a null value apparently a number of times, where we're not really sure if someone died or not. So the next step is I am going to filter out some stuff. I'm not interested in all those columns for this experiment. So I drag the module on the canvas called Select Columns in Dataset. Basically, when you drag it there, you can connect it, which I'm going to do right now. So I'm going to delete this line. You can connect one module to the other module. Click on it. In this case, launch the column selector and tell it, okay, which columns do I want to use in this experiment? So in this case, I'm only going to use the age group, the sex, the profession category, if they have any siblings, the partner, the body type, and whether or not they are going to die. We need to know whether or not they're going to die so we can train our model, because it needs to learn on its own based on all these other features whether or not you are going to die. As you've noticed in the dataset, we have a number of missing values. And to clean those up, you can drag a clean missing data module on the canvas. And in this case, I'm going to select the column siblings, and I'm going to change the missing value. So what I did by looking at the properties here, I said if there is a missing value, I want you to change the missing value with a 0, which basically comes down to if we do not know if you have any siblings, we are going to assume you do not. We also have some other different options here, like we can remove the entire column, we can remove the row, or we can even remove it with a mean or a median value if we are interested. I'm just going to leave it at 0. So if we don't know if you have any siblings, you don't. Again, another clean missing data, this time for partner. Partner is a string value. It's either a yes or a no. So in this case, if it's unknown whether or not you have a partner, we are going to replace it with no. The final clean missing data value is based on the profession category. And in this case, if the profession category isn't known, we're going to remove the row. So we're going to completely remove the row because we only want people in the data set that actually have a profession category. So let's see how it looks after cleaning up all the data. And again, you can very easily do this by right-clicking and select Visualize. And as you can see, we got less rows than we had initially, but in this case we do not have any missing values anymore, as you can see here. For instance, the profession category are 0 missing values. We do have 6 different types of values that you can see here. We have a number of students, healthcare, law enforcement, television, hotel, religion, religious profession. Same with the siblings. We either have a 0, we have a couple of people with 1 sibling, and we have a few people with 2 siblings. So this is all pretty easy to use. Just connect, configure, and move on. Now, I like to clean up my data a bit further. Right now we have some numerical features and we have some string features. What I always like to do in this case is to convert the string features and make them categorical. So what I did is I launched a column selector. I selected all the various columns that have a character value, and I made them categorical. And it has one advantage, that if you visualize the data, it's a categorical feature now. So you immediately get a histogram. We also had it in the previous one, but this is a bit more cleaner. There are some machine learning models that actually require you to convert your string or your character values to a categorical feature. So now we have our data all ready and cleaned up. So what's the next step? Well, what we're going to do is we are going to add a split data module. And what this will do is it will grab our data set and it will split our data set based on a fraction we predetermined, which is 0.8, and sends one data to the model to train on, and sends the remaining 20% of the data to score the model. So we're splitting our data here, and we're going to give our model the first 80% of our data set to train against, and then we're going to use the remaining 20% to score, to see, okay, how good did you train on that 80% of data. I configured a seed here, which basically means that it will always randomly select the same rows in the same split. So all the rows will always be identical in the test or in the training set, and no matter how many times we run this experiment. So what we then need to do with the split data module is that the 80% is going to come out of this connector and the 20% is going out on this connector. So I'm dragged a module here called train module, and I connected it to our 80% of data. And in our train module, I have to tell Azure Machine Learning, okay, on which column am I actually training? What's the value I want to predict? And in this case, we want to predict a column named Death in Movie. We want to know, are you going to die in a Halloween movie, yes or no? Then the fun part starts. You connect machine learning algorithm to the train model. And what I selected in this case is a so-called two-class boosted decision tree. And the reason I use the two-class boosted decision tree is that decision trees are very quick and very easy to train, and are generally very handy to start off with. So why is it a two-class decision tree? Because we are only predicting, are you going to die in a movie? Yes. Or are you going to die in a movie? No. Which is basically a binary decision. It's either a yes or it's a no. If we were to predict multiple options like yes, maybe, probably, we don't know, or no, we were dealing with a multi-class decision tree, which is also a possibility to do in Azure Machine Learning. But again, that's not what we chose for in this case. Our data just wants us to predict a yes or a no. So I went with the two-class boosted decision tree. Again, I connected it to the train module, and then we're basically good to train our model. What I always like to do after module training is see, okay, how good did my model actually perform? So I added a score model module. This is kind of confusing, all these modules. Anyways, I connected a score model, and I connected the remaining 20% of my data set to the secondary input of my score model. So my trained model here is going in on the left side, and the remaining 20% of my data is going in on the right side. So using this module, my machine learning module will be confronted with data it has never seen before. So this is data it hasn't been trained on. So this is a good way to get an idea, okay, how good are you performing? Finally, I added a last module, which is called evaluate model. And this will give us a bit of statistical information about how good did the model perform. Now, I've already ran this machine learning experiment, but you can easily click on the Run button and Azure Machine Learning will execute all the steps you've defined. So let's take a look how that looks. So it's queuing up our task now. It's queuing up the thing we are wanting to do. As you can see here, it's queued. And right now it's going to go through our data, and everything that's done will be marked with a little green V. And as you can see, this is really quick. And it's quick because we have a very small data set. Remember, we only have like 30, 40-ish rows. And we decided to do a 2-class boosted decision tree, which are natively very quick. So let's see how we did. So first of all, I'm going to look at the score module and I'm going to visualize it. And what you can see here is this is the data, which is 6 rows, which is 20% of the data set that the model has never seen before, and we asked it to do a prediction on it. So in this case, we have a teenager, which is a female. Her profession category, she is a student. She has 2 siblings. She has a partner and her body type is slim. She died in the movie. We know that. But what did our module actually think what would happen to her? We can see that on the added column scored labels. And as you can see, our module also rated, yes, you are going to die. And it did so with a probability of 0.88. If you see a number above 0.5 in a 2-class model training, it means basically yes. If you have a value lower than 50%, it means no. So this one was pretty sure this person was going to die. The other examples, like an adult male who is in a religion profession category without any siblings and no partner, didn't die in the movie, and actually our model also agreed on that and said no, this person is not gonna die, and we have a scored probability of 0.43, which isn't actually very sure. We also have one that's rated falsely. We have an adult female. She didn't die in the movie, but our model guessed yes, you are going to die. But as you can see, the model isn't very sure on it, only with a 0.59, which is basically just a very low probability. So this one wasn't really sure. It could have been a yes, it could have been a no. So the model isn't really sure on that. If you have a huge data set, you are more interested in seeing things in a more statistical manner, and that's where the evaluate module comes in. We can visualize this, and I'm going to ignore this little graph for now because we only have a couple. We don't have a large data set, so this graph isn't telling us a lot. What's interesting here is this little matrix here of true positives, false negatives, false positives, and true negatives. A true positive means our module predicted positive and the actual outcome was positive as well. This is good. This means in 2 cases we predicted the person was going to die in the movie, and indeed the person died in the movie, so our module scored right. A true negative means our module predicted no, you're not going to die, and the data set also showed us that that person didn't die in the movie. So this is good as well. These 2 are good. A false negative means we predicted the person isn't going to die, but it actually died. A false positive means we predicted the person was going to die, but it didn't die. And these are actually very important when you use decision trees on other problems, because these can mean a lot to the result of your machine learning model. For instance, if you wanted to predict does someone have a certain illness, you would probably rather want a false positive, like okay, we think the machine learning model think this person is sick, but it turned out he didn't, instead of a false negative that you say this person isn't sick, so there's nothing to worry about, but in the end it actually turned out the person was sick. but that depends on the case when you're using your model on. So you can see a bit of information about the accuracy, and I'm only going to look at the accuracy. It says 0.83, which is generally a reasonably good performance indicator. You want this to be as close to 1 as possible, so 0.83 is actually pretty decent. So now that we got our module trained, the next step to do in Azure Machine Learning is to create a predictive experiment. And like I said before, I've already created this, but you can very easily do that by setting up a website and train a predictive experiment. Right now it says update because I already have one, but in the first time you run this, you need to create a predictive experiment. What a predictive experiment basically does is that it will create an Azure Machine Learning web service that you can use as an API to send data to, get it scored against your model, and get the scored results back again. And the predictive experiment can be accessed by this little tab here, and it looks mostly the same as the module experiment with just a couple of differences. As you can see, some modules were changed by applied transformation. Things look a little bit different. You can see our module here says surviving Halloween trained model. So this is basically the model we trained in our training experiment. So remember, in the predictive experiment, you are going to use that trained module, send data to it, and let it predict and get the prediction back. So again, we're going to use the score module. What's new here are these light blue modules, which is the web service input and the web service output. So I connected the web service input to the score module, which basically says I'm going to give the web service some data. I want you to score the data, so make a prediction on the data, and I want you to output it again. So I'm going to look at this predictive experiment, and I can easily do that through our web services. I already have the web service running. It's automatically created when you in your predictive experiment select to deploy it. I can click on it and I get some information here. I get an API key, which I will need later on to communicate to my web server, and I can test it. So we're going to quickly click on the test button, in which Azure Machine Learning will load a testing page in which we can fill in some test data and see if we get a response from the web service. The web service is actually a RESTful API, which means you can send some JSON data to it, and it will return with a JSON response. So in this case, it already filled in a bit of sample data, and we can click our test request response, and as you can see, we are getting a scored label back here as yes and a scored probability. So basically our web server is working, and the sample data that's here tells us this person is going to die in the Halloween movie. Alright, so now that we have our Azure Machine Learning web service set up, how can we use this in our application? So you can code an application and use the RESTful API of the Azure Machine Learning experiment to do a prediction on your data. What I chose to do is to generate some R scripts that basically do the same. What I did is I created a so-called Shiny app, which is a library in R, which you can use to basically create a dynamic website. I'm going to open this little file, which loads the Shiny library and runs the app called Frontend. The way Shiny works, you basically have two files, a server and a UI, which I placed in this case in a folder called Frontend, as you can see here. And the UI basically dictates, okay, how should this web server look like? How should the web page look like? And in this case, I got a header called Surviving Halloween, and I got some input fields that I named here. And I got an action button that is called process with a text field called predict, which will send it to another Shiny file, which is server. And the server is basically the Shiny backend that can handle the data you entered into the web page and process it. So I loaded a couple of additional libraries, R curl and R JSON, because we need to do a JSON call to the web service. And what I'm doing here is when a function is being run, the input the process function, which is someone clicked my predict button, I'm going to get all the values of the information that people filled into the form, the HTML form, and I'm going to do set these to some variables. What I'm then basically going to do, I need to push them to Azure Machine Learning in an R list, which I'm doing here. So I'm creating an input list that the web server requires, and I'm going to convert it to JSON. I need to get my API key here and my URL, and then I can do a call to the RESTful API. So this is basically all code you need to use to do a prediction against your Azure Machine Learning web service. Finally, I'm going to have an output, and I'm only interested in one field in the output, which is called prediction. I'm going to render the prediction as text, and I'm going to pass it back to the UI. So here in the UI, I have a text output called prediction, which comes basically back to what we got from our web servers. So how does this look like? It's very easy. We run this code, and RStudio will open up a web browser, which I'm going to make a little bit bigger. And we got some information here. So first of all, I got the text, are you going to meet a horrible end in Halloween? Fill in your characteristics and click the predict button. So I'm going to fill in some information. I'm an adult, I'm a male, I work in IT, or maybe data. Who knows? I actually have one brother. I do have a partner. I'm sorry, I'm already taken. My body type is, this is a difficult one to do on YouTube. Let's say I have a normal body type. As soon as I click the predict button, this data will be pushed to the server.r file of Shiny. It will get put inside a JSON format, uploaded to Azure Machine Learning, where our web service will process this data against the model we trained, and it will return a prediction. So let's see if it works. Yes, I am going to die. That's a bit of a disappointment. I always guessed I would survive. Oh well, anyways, you know, it's statistics, it's data science, so yeah, I'm not gonna survive a Halloween movie. So to sum things up, in this video we try to predict whether or not you would survive a very specific slasher horror movie called Halloween. We used Azure Machine Learning to upload a data set, process the data set, remove missing values, do all that fancy data preparation stuff you need to do. We train the model in Azure Machine Learning, and we use that model to create an Azure ML predictive experiment. The predictive experiment is, like you've seen, a web service. So we used a bit of R code in combination with Shiny to create a web interface where we can fill in our own characteristics, upload that data to Azure Machine Learning, do a prediction based on the model we train, and return whether or not we're going to die in a Halloween movie. Unfortunately, I died, which is a big disappointment for me personally. I always thought I would survive, but you can try it yourself as well. As always, I've uploaded all the code I worked on to the Crazy Data Science GitHub repository, including a runbook at how you should configure your Azure Machine Learning experiment if you want to reproduce the results. So that's it for this video. I hope you've enjoyed it. As always, if you like this video, show it a little like or subscribe to our channel. There are more Crazy Data Science videos coming up soon. And if you have any crazy ideas, just send them to us on Twitter or send a comment in the bottom of this video. Thank you very much for watching.